CPU is the central processing unit of the computer. Its function is to process the information in memory. CPU normally consists of 5 basic components: random access memory, registers, control unit, arithmetic logic unit, and buses. Random access memory holds data that is to be processed. The data stored in RAM relates to any operating program and is only stored while a relevant program is in use. These are fast access memory locations. In this case there are 3 registers: instruction register, program counter, accumulator. This unit simply controls the flow of data within the CPU. This control unit is made up of a decoder and a multiplexer. The ALU carries out all required mathematical calculations and carry out all mathematical operations on binary numbers. Buses are the wires that transfer data around the CPU. There are 3 types: data bus, address bus, and control bus. A Neumann architecture is made up of 3 basic components: CPU, RAM, and input-output circuitry. It is connected via buses. There are 3 main buses: control bus, address bus, and data bus. How does it differ from today's computers? Today's architecture has some additional components, mainly the North Bridge and South Bridge. The North Bridge is responsible for very fast processes between the CPU, RAM, and graphics output. The South Bridge is responsible for the slower processes: reading and writing to the hard disk drive, input and output from mouse and keyboard, and communication with other devices like sound cards and network interface cards. The fetch and execute cycle is the time period of which the computer reads and processes instructions from the memory and executes them. This process is a continuous cycle which is used until the computer is turned off or until there are no more instructions to process. What happens during the process? First, the program counter fetches the next instruction, example, load memory location, into the accumulator. Next, the instruction is decoded. This instruction is then executed. The program counter then fetches the next instruction, example, add 2 to the accumulator. This instruction is then executed, which gives us a result of 7 in the accumulator. The next instruction is then retrieved, example, store result 7 in memory. This is then executed, and if there is no more instructions, the program ends.